The authors of this video present
Build your own artificial intelligence software for free to diagnose retinal diseases.
The authors have no financial interest in this presentation. In movies, artificial intelligence is depicted as powerful, good or evil. But is this fact or fiction? AI is everywhere in modern life. Let us look at the definitions of artificial intelligence. It is a simulation of intelligent behavior in computers, and machine learning is where it automatically learns and improves from experience without being explicitly programmed. So where are we now? The fourth industrial revolution with the cyber-physical system. Research and publication on AI in medical science is undergoing a rapid surge now. Various subspecialties of medical science use AI. Not only ophthalmology, radiology, dermatology, cardiology, pathology, oncology, pediatrics, endocrinology, gynecology, and so many more. There is a lots of imaging and big data in ophthalmology. Slit lamp photographs, retinal fundus photographs, optical coherence tomography of the anterior segment and retina, fluorescent angiography, A scan, B scan, corneal topography, intraocular pressure values, refraction and spectacle power, visual fields, and so much more.
Ophthalmology has several diseases which are being analyzed by artificial intelligence, such as diabetic retinopathy, glaucoma, age-related macular degeneration, retinopathy of prematurity, retinal vascular occlusions, keratoconus, cataract, refractive errors, retinal detachment, analyze the progression of squint, and much more. AI is used for IOL power calculation, Hill RBF and Ladas formulas, and planning squint surgeries and anti-VEGF injections.
Research from Google's Verily Health Sciences division showed that a single fundus photograph can be used to determine the age, gender, smoking status, HbA1c value, and BMI of a person. You can also detect cognitive impairment, dementia, Alzheimer's disease, stroke risk, and cardiovascular risk. This is an article about the role of AI in ophthalmology that I published in the Kerala Journal of Ophthalmology. CyberSight website from Orbis allows you to analyze fundus photographs with an AI for free. Finally, let's get started with building our own AI. On the right side are test fundus photos taken randomly from the folders on the left. So on the left you see the ARMD folder and you see the test photo is different. And here is the BRAO folder. And there's a CRVO folder, and see that this fundus photo and this fundus photo are different. They look quite similar. We'll come into that later. This is the macular holes, the retinitis pigmentosa, and subhyaloid hemorrhage.
Let us start building the AI. First, you need to go to the teachablemachine.withgoogle.com website, and once you get to that page, click Get Started. You can open an existing project from your drive or from a file. There are three types: image, audio, and post project. We will be doing an image project, and we will be taking standard image model. Embedded image model is for microcontrollers. So first we have the classes. So we first name the class and put the particular image data into that class. So that is the ARMD class. Now the second class, I don't know what it is, so let us first put the images, and then let's see now. Yes, BRAO is there. So I took this folder full of BRAO photographs, and now I name that as BRAO.
So once that is done, I continue in the same way and add a class for the other image categories. So now I am going to insert one for the next one, which is a BRVO folder. And what is once that is entered, I name the class as BRVO, and so on.
A few minutes later.
Now I have completed subhyaloid hemorrhage, retinitis pigmentosa, macular hole, and other classes. It is time to start the training. So in this, I can change some parameters. I increase the epoch to 200. And let's see if that is enough. Spoiler alert, it is not enough. Now that the training is going on, we can look at some of the other settings and understand what these are. So there are epochs, batch size, learning rate, but also note that you should keep this open. You should not close this tab. So while the training is going on, batch size is the number of images that are simultaneously trained. Learning rate is usually kept at 0.001. Epoch is the only setting that you really need to change.
Oh look, the training is already complete. So I switch over to the preview. I select file, keep the input to on, and select a file from the test images. So I go to the test images folder, and these are all the test images. I'm going to select one of these, say the subhighlight image. Note that these are not there in the training images. The AI is confused whether it is a choroidal rupture, CSCR, or a subhighlight hemorrhage. Finally, I ended up removing many of the classes and increasing the epoch to 5000.
2 hours later.
After running the epoch for 5000 and reducing to just 6 classes, it worked out. ARMD, BRAO, CRBO, macular hole, and retinitis pigmentosa, and subhighlight hemorrhage. Finally, I opened the preview again to file, and first turn the input to on and select a file from the desktop, and I go to the test images and check ARMD, and now it has detected it at ARMD 99% certainty, and even this one, it is detected as BROO with a very high level of certainty. And let's see the others also, that is a CRVO 100% certainty, because there's a very similar image in the training set. And this is a macular hole which is 99% certainty. Another one, let's see the retinitis pigmentosa. It's getting confused between CRBO and retinitis pigmentosa because that is the structure of the lesions, the spread of the lesions. And this is a subhighlight hemorrhage, a very good certainty. And note that all these test images are not in the learning data. To export it, you can click export model, and you can export it as a TensorFlow JS or an actual TensorFlow Python script or a TensorFlow Lite to put in a microcontroller. Let's go with the TensorFlow JS and upload it onto the cloud, so onto a website supported by Google for free. It takes a bit of time to upload the model, and now the cloud model is up to date. And if you look up there, there is a link to the cloud model hosted on Google's website. I copied the link, and this link can be shared to anybody. So once you share this link and open it, it opens this, and I open a file, input on, and select one of these test images or any test image, and it will be able to detect what that is with a very good amount of certainty based on the training data. So that is all, folks. Hope this inspires you to create your own AI for free.